Hi everyone. So I'm Oscar, and today I'm just going to be talking a bit about using honeypots for threat intelligence. So just to introduce myself, I'm a second-year cybersecurity student at the University of Warwick. I'm also the technician for the Warwick Cybersecurity Society, and that's my Twitter. Not that I tweet anything. So first of all, given we're talking about honeypots for threat intelligence, it seems to make sense to explain what a honeypot is. So this is a description from Chris Sanders' very good book about intrusion detection. So honeypots rely on deception to encourage attackers to interact with them and then generate alerts so that you know that you've been connected to. But the difference is, obviously that book I just talked about is about intrusion detection. Usually, if you have a connection to a honeypot, the traditional thing to do is panic, because that means you've got someone on your network. But with threat intelligence, it's exciting to us if someone connects to it, because you get some valuable data. So what you want to do is take these attacks, encourage as many of them as possible to connect to you and get information such as IP addresses, what credentials have they used to log into your server, and other things like URLs, keys, wallet addresses, because there's a lot of crypto, etc. So over the summer, I worked on an open source project called ThreatDash, which took the pre-existing SSH honeypot called Cowrie, which some of you might have heard of. It basically emulates an SSH session, but it doesn't actually run anything, which is a key distinction. And then what I did was I converted the data coming out of that, stored it in a MongoDB instance, including the files that you see uploaded, etc. And then you can carry out signature analysis of it with Yara signature detection rules. So this honeypot was hosted on the University of Warwick public IP address, which originally I tried hosting it on AWS, but you get a lot less connections when you're hosting it like that, presumably because a university is a targeted institution. So this graph here shows the sort of attack volume you saw per day across a period of about 3 months. So the blue line you see there is how many connections there were that tried to log into the SSH honeypot. And then the orange line shows how many of those sessions actually executed commands, because you saw a lot of sessions that were created, someone logged in, but they didn't actually run any commands, so presumably just trying passwords across the internet. Now, the question we had to ask before moving any further with this is it really worth it to put all this effort into it? Because you can get a lot of valuable information just from IP addresses and commands, etc. But you can always get more information by running more detailed analytics on things or trying to make a honeypot more realistic. But the further you go, each time it requires more effort, and eventually you reach a point where you can spend weeks on one single thing that doesn't really return anything of much value. So it's a trade-off between you want to maximize what the output is, but you don't really want to spend too much time on it. So the aim of this project really was to take a data set of about 28,000 interactions and identify unique attacks. So being able to look at an attack and go, oh yes, I recognize this from a certain attack. So first thing we used was MITRE ATT&CK, which allows you to tag it to certain techniques. But I'll admit I'm not very familiar with MITRE ATT&CK, so trying to write it like that was quite hard. I was able to identify about 19 tactics, or techniques actually, when about 224 exist. So obviously, I most likely missed some of the techniques that MITRE ATT&CK lists, but at the same time, it's not an easy thing to work with, and trying to look at a set of commands being run on an SSH session and map it to MITRE ATT&CK, it's not that easy. So then the way which I tried to look for unique attacks was look for unique combinations of MITRE ATT&CK techniques. And using that, I was able to identify 51 different attacks. But when you start to drill down into that, because you only have 19 possible techniques, there's a lot of overlap where you saw attacks that were clearly very different being categorized under the same thing. So just to give an example of this, we looked at the system information discovery technique from MITRE ATT&CK, where an attacker tries to get some information about the system. When an attacker out there on the internet is connecting to a random IP address they found, that's most attacks. Most attacks are trying to learn something about what they've discovered. So here I've got a few examples of things that came under the system information discovery technique. And as you'll see, they're quite different. So putting them under one technique was quite a broad thing, really. So you saw attacks that tried to read the binary for echo, which is a traditional tactic used to try and identify if the system architecture is 32 or 64-bit, because you can read the ELF header. /IP cloud print. If you look that up, you know that they're trying to target MITRE ATT&CK routers. So, because that's a command specific to that. And the NVIDIA SMI command, you know that the attacker is looking for information about the GPU, so most likely trying to do some crypto mining. So, if you actually drill down into the specific commands being run, not just the MITRE ATT&CK technique, you start to realize that you can get more about the context from it. So the solution to this was, rather than using MITRE ATT&CK, I basically just took the commands and manually went through them and categorized them into unique individual things. I tried experimenting with string similarity sort of things, where setting a threshold if the strings are 60% are similar or something. That didn't really work out. So instead I went to Yara rules and just trying to write signatures for each possible attack. Because, as we saw before, MITRE ATT&CK just tells you what tactic's been used, but it doesn't give you any context. So these Yara rules with notes and things, you were able to identify what specific OS was being targeted, what was the aim of that attack, what exactly are they trying to do. And also, because a lot of these are automated, you see very unique usages of certain commands. For example, as you see in the Yara rule on the slide, there's a very specific usage of the uname command with several arguments in a very specific order. And as it's automated, that attacker always used the arguments in that order. So I have several rules in the dataset which are just looking for uname commands, but with arguments in slightly different orders or different permutations, because that was able to uniquely identify an attack. And the comparison there was, I was able to identify, as I said, 51 unique attacks with MITRE ATT&CK. But then when I started writing these custom signatures, I was able to get that up to 100. So that started to reveal the breadth of what was actually in the data set. And as I said, Yara signature rules, as a defined format, you can also write comments, add notes. So reviewing it is a lot more useful. So just to quickly explain the sort of things we're seeing in this data set, it turns out when you put a SSH server which anyone can log into on the internet, basically people are trying to crypto mine. At least 17% of all attacks seen, and this was attacks with commands, not just general connections, explicitly did something relating to crypto. That number is a massive underestimate, because there are a lot of attacks which I didn't go into in depth, but they were downloading shell scripts and running it. And when you start to look at those, most of them are also crypto mining. So what were these crypto mining attacks looking for? Well, a big one was looking for Hive OS systems, which is a distribution specifically for crypto mining. You can tell that because it's using a specific command, Hive password. Or it's looking for VNC passwords.txt, because apparently Hive OS stores its VNC passwords in plain text, and also a configuration file. Also saw a lot of xmrig, which is a miner, so you can identify that by spotting the GitHub download link. And there, you've got another interesting indicator that you could use for threat intelligence, because a lot of the commands had the wallet addresses in them, so you could use that and use it to map again later. And there are a lot of other different crypto miners being downloaded or looked for, etc. So the other thing about honeypots is, obviously, as I said, they rely on deception. So you have to have an attacker believe that they're real. And if an attacker, obviously what we've seen so far is mostly automated attacks, but if you have an attacker who actually knows what they're looking for, is hands on keyboard and starting to look around, it suddenly becomes quite easy to work out if you're in a honeypot or not. So first things first, if you've ever used Cowrie, you'll know it has a default hostname of server 04. So any attacker who knows what they're doing would see that hostname and immediately log out, because they know they're in a honeypot. So the very first thing you want to do is change that. I think the instance I have running uses production as a hostname. Hopefully that seems appealing to an attacker. Well, the other thing I mentioned is Cowrie emulates its commands, so it only knows what's programmed into it. So, for example, a lot of attacks I saw over the summer, they were looking to read the uptime file, to see how long the server had been up for. That didn't exist at the time in Cowrie, so I decided to add that, because not even dynamic. I just put a file that had a number in it, actually. And hopefully to some attacker, that's going to make it seem a little bit more realistic. Because if you log into a system and you can't find proc uptime, you might start to have questions about what's going on. The other thing that was missing was the lspci command that talks about the PCI cards available on a machine. So my first instinct for that was just to create a command, run that command on my local machine and copy the output. But the important thing, as you can see in this picture here, is that because I was currently doing my work in a virtual machine, and that's one of the ways an attacker uses to detect virtualization. So whilst that might not suggest honeypot, that might suggest to an attacker that they're in some sandboxed environment, potentially putting them off giving any information that might be useful for threat intelligence. So I had to be very careful to look for a output that didn't indicate any form of virtualization, just to make it seem a little more appealing to an attacker. So the question at the end of all this is it honeypots? Are they worth it for threat intelligence? And the answer to that is if you put a box on a random IP address on the internet, it probably won't be that interesting. You just see a lot of botnets, crypto mining, etc. Nothing really that new. But as is sort of seen by putting it on a university IP address, if you're some organization that's perhaps of interest to specific threat groups, you might start to see something more unique. So if you're particularly concerned about your threat model, having a honeypot for threat intelligence might be useful. The other thing is you just have to be patient. It took a long time, days before anything interesting came through. So just to sit tight, and some days you'll get loads of attacks, some days you get nothing. And the other thing is, most of the attacks you'll see, they just have been reported on. It's very easy to take something you see, be excited about it, and then just look it up and someone's done a really good write-up of it. So you're not really generating anything new in terms of threat intelligence. But the reason I'm talking about it today is because it was just fun in the end. Like, you don't really discover anything new, but at the same time you get to see what's going on the internet, have your own idea of who's scanning what, etc. Yeah, so thank you. Any questions?
Wow, thank you. I wish I'd had one of those at school. Would you have liked to have had the opportunity to mount any of the address space not currently then in use at the university? And that would obviously reduce the probability significantly.
Would you be able to repeat the question, sorry?
Yep. So assuming your university has a block of address space, would you have liked the opportunity to have mounted any of the spare address space with honeypot servers, perhaps redirecting to your one, and then potentially much reduce the probability and therefore see significantly more activity?
Yeah, I mean, I haven't really sort of thought about in depth about in terms of the effects of the IP addresses. It's I kind of just used what I was given, but I think trying to explore that more in depth would be definitely very interesting.
Any more questions?
If you're putting something on the internet to be exploited, just to kind of see what they're doing, do you kind of worry that someone might try and use your resource that's hosted and used by you to, let's say, stage indecent images or other things that potentially could come back to you?
Yeah, I mean, that's definitely a worry. That's kind of why the model behind Cowrie as a sort of honeypot is that it's entirely emulation-based, because nothing that's run actually gets done. I mean, saving the files, you are saving anything indecent that's uploaded, etc., but not publicly. So I don't think, in terms of emulating it, there's any particular concern there.
Did your honeypot get any sort of actionable information that you were able to share during the 3 months that you had it running? You don't not necessarily share with us, but
I do. There is like a list of IP addresses and things. I tried to sort of exporting all that. I mean, there is information to be shared, but nothing that isn't already out there. Like all these IP addresses and things are being mapped by like bigger threat intelligence things anyway.
Do you have any sort of future research questions or any other sort of queries that you think you'd like to answer with a similar kind of set of experiments?
I think the interesting thing that was considered out of this was, can we do the same for sort of Windows and RDP? But the answer to that was also, Windows is just a lot harder to work with, and trying to emulate that is a challenge. So it'd be about looking to actually sandbox a Windows environment.
Thanks. One of the interesting things about doing Honeypot, because when you first started, I was thinking, actually, what's the use, or how could I apply this? One of the things probably, because my background is more GRC, a lot of the things people probably struggle with is understanding the real value of an asset. So actually, I could see if you were to deploy a series of honeypots that might indicate that someone could have access to a specific asset, maybe in terms of university, a bit of research or something that's being done, that can actually allow you to classify or get a real value generation of actually how much is this specific asset worth, what's the likelihood that someone would want to try and access this, and therefore feed into your risk assessment. So that I think is quite interesting. Is that something you thought? Are there other applications along that kind of same line of thinking, or any other applications you think could also honeypots could be used for? Or
yeah, no, definitely. I think that's the sort of point trying to make about the specific companies. It might provide a specific value. Like obviously, the context I was doing it in was just general internet-facing honeypots. But I can imagine it allows you to, if you were to try and emulate something that you were specifically interested in, like trying to emulate the characteristics of that, I could give interesting information and also a bit of idea of what it's actually targeting your organization. Yeah, definitely. So, because that's the sort of information you can get, you can start to like tag IP addresses, any other sort of indicators, and so you can really build up your own sort of internal threat intelligence on that.
Cool.
Did you try different output in LSPCI? So if you included a high-performance graphics card, you would see them do further commands versus disconnect?
Can you say that again? Sorry.
So with LSPCI, you could include an NVIDIA graphics card. Did you look at if they run further commands after they found the graphics card versus not finding one and just disconnect?
Yeah, so definitely with the commands about GPUs, you were often seeing greps for certain patterns. The interesting thing that I did find in terms of a lot of those greps is that it never seemed to particularly affect what the attacker actually ran afterwards. It seems a lot of attackers seem to collect information to store for themselves, but never actually do anything. But yeah, I definitely try to make the LSPCI look a bit more enticing with sort of NVIDIA graphics.
Obviously, by putting it on a university network, did you have any like ethical concerns had they broken out of your kind of virtual environment?
Not in far as the way it was set up. Like I was very lucky to have a very skilled sort of technician who I worked with, who made sure it was a sort of very on the public IP address range, but it was in an isolated lab environment and it was properly firewalled, etc. So there wasn't any risk to that.
Is that all? Yes? Yes? No? Any more questions? Last call? No? Excellent. Well, if we want to give Oscar, yes?
Yeah.
Yeah, a round of applause. It was excellent honeypot.